Welcome back everyone, and in this video we will try to discuss the topic of the vectors which is required to learn physics at 11th and 12th level. So we will have a discussion mostly related to the vectors and how to apply the mathematics of vector addition or multiplication in physics. Okay, so entering into the chapter, let's have a basic understanding about what a vector means with the help of an example. Okay, let's take an example which gives us a good idea about what a vector actually is. So the first one would be, let's say I have two beakers or two boxes, whatever you want to call them. Let's say in the first beaker I have 5 liters of water. So I have filled the first beaker with 5 liters of water, and the second beaker has been filled with some 2 liters of water. Okay, whatever water or whatever the liquid you want. So I have two beakers separately. One of them is filled with 5 liters of liquid, and the second one filled with 2 liters of same liquid or a different kind of liquid. And now if I take these two beakers and if I pour them, I take the two of them and empty them into the same beaker. Now what will be the total volume of the liquid that is present in this beaker after you take these two bowls and empty them into this beaker one? Then in such situation, the total volume of the liquid present in this beaker would be 7 liters. Okay, 7 liters of liquid will be present in this beaker. Then how can we say that it's 7 liters? Because it's just 5 plus 2, so the total volume present in this beaker will be 7 liters. And now try to understand the same question in a different context or with a different physical quantity. Here we are taking the physical quantity to be the volume. Now let's take some other physical quantity and try to understand it. Let's take an example. Let's say we have a box of some box. Regularly we come across the boxes in day-to-day life. So let's say I have some ideal rigid box which is placed on a surface which is smooth, or you can also call it frictionless surface, which means that there is no friction that can act between the block and the surface, whatever the situation is. Okay, now I have this block of mass m placed on a smooth surface or a frictionless surface. Now let's say I have started applying some force on it in this direction. So if I apply some force on it, I am pushing it in the right direction, then everyone knows by common sense or by the way of observation with real life objects, everybody comes to a conclusion that the body really moves to the right side. The body moves towards the right direction. Okay, I think this is obvious. And let's ask ourselves a different question. Let's say we have the same block again, kept on the same surface, which is again smooth. I will write that over here. Now again kept on a smooth surface or frictionless surface. But in this situation, let's say we have, instead of a one person pushing the block, let's say we have two people pushing it. Okay, one person is trying to push it towards right with the force F. Okay, somebody is trying to push it towards right with this force, and the other one or the second one is trying to push it towards left with the same force. Okay, so in the second situation we have taken the same block, kept on the same surface, same horizontal surface, which is smooth, which means that there is no friction acting between them. But in this case we have two people pushing it from opposite directions and with the same magnitude of force. But what we can conclude from this is, so if you look at the forces, they are acting in opposite directions. So we can say that by our common sense. So if the block will be at rest, something like in the case of a tug of war game. If we have two teams present on the opposite side, if they are pulling the rope in both the directions with the same force, there will be no movement on either sides of the team. Okay, the same thing can be applied here. Okay, the block will not move in this case. See that we have two forces acting on them, but the block is not moving, or it is at rest. Or can I say that the force acting on the body is zero? So if a force is acting on the body, it produces a motion in the body. But in this situation, even though the forces are acting, there is no motion in the body. Or can we conclude that the force, since there is no motion, can we actually conclude that there is no force acting on the body? But we can't conclude that. There are actually forces acting on them. Okay, then what's the difference between this case and this case? Okay, in this case, there is a force acting on it, produced a motion. But in this case, there are two forces acting in opposite directions, whose total sum of forces becomes zero, or the total effect produced by both of them is zero, or the effect that can be produced by one force is cancelled by the effect produced by the other force. What we mean by this is the forces are cancelling each other, or we can say the sum of these two forces is equal to zero. Okay, we can say that. But let's take another example where I'll take the same forces, but instead now they act in the same direction. Now the two people who are present in the opposite sides started cooperating, and they started pushing the block in the same direction with the same force. But in this situation, we can say that the block definitely moves in this direction. Okay, in this situation, the block will definitely move. So if you want to feel it, you can actually take some object in the surroundings present around you and perform this. Okay, and what's the reason? Here we had the same two people applying the same force F. Here also we have the same two people applying the same force F. But the difference is that in this situation, one of them changed their directions of applications. So here, direction of application of the force has changed the total output or the total result produced by these forces. So here, which was at rest, but here changing the direction produced a motion inside the body. So what we can say is, in this force, not only the magnitude or the value of the force matters, but also the direction in which it is acting. Okay, so we call such quantities where magnitude and direction are important. Okay, such quantities are called vector quantities. Okay, so I have taken the force example in order to explain this because it gives us an easy intuition into the subject of understanding of the vectors, why the study of the vectors is required. Okay, and you can also understand the importance of vectors with the help of a door. For example, applying force in one direction closes the door, but whereas applying the force in the opposite direction opens it. The same force, even though you apply the same value of the force, or value is also called magnitude here, even though we apply the same magnitude of force in the both situations in opening and closing, but what really matters is in the direction of the force in which it's applied. That also makes a difference in deciding the nature of motion. Okay, so this is why we have two different quantities. Here the directions did not matter when you wanted to calculate the total volume. Okay, because volume is a scalar quantity or a physical quantity which only has magnitude. In this situation, 5 liters, 2 liters, here 7 liters. But there are some physical quantities in which case Direction is also important. So we call such physical quantities as vector quantities. So in order to deal with such vector quantities, we had to come up with a special kind of mathematics which helps us to analyze situations where vectors are involved. So now we will get into that part of mathematics which gives us a way of understanding the vectors or dealing with them. Okay. And first thing you need to remember the difference between scalars and vectors. Scalar quantities have only magnitude and they do not have any direction. But when it comes to the vector, vectors have both direction and as well as magnitude. Both are important. And let's say a few examples for the scalar quantities are mass, volume, as I said earlier, volume, and pressure, mass, energy. Okay, still there are so many other physical quantities, and a few vector quantities are force, direction matters, okay, velocity, displacement, acceleration, direction matters, and so many other physical quantities which you will come across in your study of physics. Now let us get into the understanding of the mathematics of vector quantities. Okay, now before going further, let's give a basic design, or not, it's not called a design, or basic way of representing a vector. So whenever we have a vector quantity, let's take the force for instance. Okay, force is a vector quantity. Okay, whenever you apply a force, let's say you are applying a force of 10 newtons, and in which direction? Let's say in this situation, right direction, from this direction to this direction, let's say in this direction. Now how I represent this force is, I draw an arrow, or it's called a ray. This point is called a tail of the vector. This is called head of the vector. Okay, so the head of the direction of the head of the vector represents the direction in which the force is acting, and the length of this vector represents the magnitude. Okay, so for example, let's say 1 centimeter of length of this vector represents 1 newtons. Then if you want to represent 10 newtons, then 10 centimeters equal to 10 newton. Okay, so I have taken a scale in such a way that 1 centimeter of the length of this vector, if it represents 1 newton, then if I want to represent 10 newtons of force with this particular scale, have to draw the length of this to be equal to 10 centimeter. But actually this is not 10 centimeter, it will definitely be greater than that. It is just a rough diagram. Okay, this is what we mean by the length of the vector being equal to the magnitude of that particular vector. Okay, so this is the way of representation of a vector. This is called tail, head, and the direction of the vector is given by its arrow, and the length of the vector represents the magnitude of that vector. Similarly, if I have a vector equal to 5 newtons, okay, and in the same direction, I may have to represent something like this, with the length equal to half of this length and in the same direction. So this is head and this is tail, okay, of that particular vector which has magnitude of 5 newtons. Okay, so this is the basic representation of a vector. Okay, now let's try to understand next a few things related to the vector quantities. Okay, and before going further, let me explain a few types of vector quantities which we will be coming across throughout the entire chapter. And the first one I would like to call null vector. So I am only telling those vectors which are important in physics and you will come across a detailed study of this vector quantities in mathematics, but here I'm only trying to explain that which is required for the study of physics. Okay, the first one is a null vector. Null represents nothing or 0. So in this situation, vector with magnitude 0 is called null vector. Suppose if you have a vector which is magnitude is equal to 0, then it's called a null vector. And remember that a null vector, if it has a magnitude 0, then the length of that particular vector when you represent in the form of that arrow must be equal to 0. Length being equal to 0 does not make any sense. Okay, so the null vectors do not have any particular direction or any magnitude. They do not have any particular direction and magnitude. And next, what you need to understand is unit vector. Unit vector means 1, or unit vector, a vector with magnitude, the same thing again, with magnitude 1. Okay, any vector with magnitude 1 can be called as a unit vector. And next, what we have is parallel vectors. Parallel vectors. Okay, the parallel vectors, parallel, or two vectors which are in the same direction. Let's say we have two vectors, a bar. A bar means this vector. Let's say bar here, it just indicates that a vector. Okay, or you can also represent arrow, something like this. So we have two vectors in the same direction, towards right direction, or two vectors along north direction, or two vectors along south, two vectors along northeast. Okay, so if we have two vectors which are in the same direction, they need not have same magnitude, but if they are in the same direction, then such kind of vectors are called as parallel vectors. They are in the same direction. And one more thing about the parallel vectors is that if we have two parallel vectors, the angle between them will be equal to 0. Angle between them will be equal to 0. Okay, they are in the same direction and angle between them will be equal to 0. And the next one is something called the opposite of parallel, being anti-parallel vectors. So anti-parallel vectors are those which are in opposite directions. So parallel vectors are in same direction, and let's take C bar. So here, if you have two vectors, something like A bar and C bar, which are in the opposite directions, okay, exactly opposite, then if this is something like towards right and this is towards left, or east and west, north, south, something like that, then such kind of vectors are called anti-parallel vectors. They will always be in opposite directions. Okay, and angle between such vectors is 180 directions, and they are opposite in directions. They are opposite in directions. Okay, so and the next one is something called coplanar vectors. Coplanar vectors. What coplanar vectors means is that, so coplanar, being in the same plane. Suppose if we have two or three vectors or any other vectors, if they are in the same plane, okay, two vectors will definitely be in the same plane. Okay, it does not matter, it's not important to speak about two vectors. If you have vectors more than two, and if they lie in the same plane, for example, if I have three vectors, A bar, C bar, R bar, P bar, all of these vectors are in the plane of this board, then I can call such kind of vectors which are in the same plane as coplanar vectors. Coplanar vectors being in the same plane. Okay, if you have two vectors, they will definitely be in the same plane. So whenever it comes to the coplanar vectors, then if they are greater than 2, then we can see, we can say whether they are coplanar or not. But if there are only two vectors, they'll definitely be coplanar vectors. And the next thing is something called, I will erase these things. the next thing is something called negative of a vector. Negative of a vector. What does that mean? Let's say I have a vector, a particular vector in this direction. Let's say a bar. Have the vector a bar in the right direction. Okay, right? This is not exactly straight line. Okay, this is just a rough diagram. So I have a vector a bar in the right direction. Let's assume its length or also called the magnitude. Let's say the magnitude of this is a. We generally so a bar represents this vector, and these two vertical lines to the left and right indicate that we are trying to speak about its magnitude. So it means the magnitude of that vector, or we can also call it mod of a bar, which is a, which gives us the magnitude of vector. Now if the magnitude of the vector is a and it is towards right direction, okay, a bar towards right direction with magnitude a. Now if we have another vector which is multiplied something like with a minus, so minus of a bar or negative of a bar, what this means is that this is nothing but it's multiplied with -1, and this vector will be opposite to the direction of a bar. Okay, if a bar is towards right, minus a bar or negative of a bar will be towards left, and both of them will have the same magnitude. Magnitude of both of them will be same, or lengths will be same, but what that minus does is it changes the directions. Those two vectors will be in the opposite direction to each other. So this is what is meant by negative of a vector. So negative of vector a bar is minus a bar represented in this situation. Okay. The last one, and I guess one of the most important ones, is something called position vector. Position vector. Okay. So we need to understand this position vector very carefully, because we come across this in most of the physics. Okay. In kinematics mostly. Okay. Let's say we have XYZ coordinate system. XYZ coordinate system, X, Y, and Z. Actually, Z is something like out of this board, but since I can't represent a 3D diagram in this, I'm representing Z something like this. Imagine it to be something like this. Now, if we have a point somewhere in that XYZ coordinate system, or in that 3D space, okay, a 3D space. Now let's say I will draw an arrow from here to here. So this is, let's say this is point P, x comma y comma z. I have point P with coordinates x comma y comma z. Then the position of vector of that point P, okay, position vector of that point P is nothing but a vector with its tail at origin and with its head at the position of that point. Now this, or let's call this P bar. Okay, you can represent it with whatever you want. I'm just calling it P bar because we have taken this point to be P. Okay. Now the P bar with its tail at origin and with its head at that point x comma y comma z represents the position vector of that point P. Okay, the magnitude of this position vector is nothing but distance between that point and the origin. Okay, so if you are familiar with the mathematics, we can directly say which is equal to root of x square plus y square plus z square from coordinate geometry, and magnitude is this and direction is from origin to that point. So what this position vector definitely gives us is that the position of any point with respect to origin. Okay, it gives us the distance of that point from the origin, and as well as it gives us the direction in which it is present. Okay, that's what position vector is. So you need to understand the meaning of a position vector. So the position vector of any point gives us the distance of that point from the origin and as well as the direction in which it is present. We'll discuss most of these things in the upcoming videos. For now, these are the most important vectors. Okay, we'll come across them in each and every topic or subtopic we're going to discuss in this chapter of vectors. Okay, for now these are the types of vectors. And next what we will be discussing is how to find a resultant of two vectors, or simply to call sum of two vectors in this case. So in the previous example I explained, when I had two beakers filled with liquid in both of them, the total amount of the volume is the sum of the volumes in the individual beakers. But when it came to the force, the direction must also be considered, right? So how do we calculate the total force in that case, or how do we calculate the sum of two vector quantities? So the sum of two vector quantities can also be called a resultant of the two vectors, okay, or resultant of three vectors or four, whatever it is, depending on the situation. Okay. Now in order to evaluate the resultant of the vectors, we have a few methods to evaluate them. The first thing will be the triangle law of vectors, okay, polygon law of vectors, and parallelogram law of vectors, and so on. In the next video I will be discussing how to find the resultant of the vectors. Okay, have a great day.